Now we're going to be working with complex numbers. There were certain equations that we worked in this course for which there were no solutions as real numbers, and we needed to extend our number system. And so that's what we're doing when we're working with complex numbers. In this segment, we're going to define a new number called I. We're going to define a complex number, and then we're going to look at powers of this number I. But let's backtrack a little bit and see why it is that we need to consider an extension to the number system. Suppose that we're asked to solve 4 equals 0. Both sides of the equation. Notice that on the left we would have a positive number, and on the right we have a negative number. There is no real number which is positive which is equal to a negative real number. That's not. We're going to introduce a new number and define I such that if we square I, we will end up with a negative 1. Now you notice that that can't happen in the real numbers because the square of a number is positive. It can't equal a negative. It's not a real number. We're going outside of the real numbers. Well, by doing this definition, what we're also saying is that this number I is going to be the square root of negative 1, which, as we saw before with real numbers, we cannot take the square root of negative numbers. All right, so I is called the imaginary unit. And we're going to define a new set of numbers, which are the complex numbers. Define a complex number this is a P, complex number, to be a number which is written as A plus BI. It comes in two parts. Okay? The A and B are real numbers. The I is the imaginary unit. So, examples of these are or we could have a negative 1/5 minus I. Because a negative 1/5 is real, negative 1 is real, so it's in the form of A plus BI. That form, by the way, is called the standard form for a complex number. Okay. Now, what about a complex number? Okay. For example, let's look at the number 2. If it is a complex number, A plus BI, right? So can I write 2 as the number A plus BI? Sure, because we can write 2 as 2 plus 0I. That's in the form of A plus BI. Okay? So real numbers are complex numbers. In fact, you can think of complex numbers being in a set like this. Real numbers but there are an awfully lot of complex numbers which are not real numbers at all. In fact, the number I is not a real number, so that's going to be somewhere over here. The number negative 3I is going to be somewhere over here. The number 2 plus 3I, a bunch of numbers which are not real numbers, but the real numbers are part of that set. Okay? All right, now let's go back and look at this I. Root of negative 5. Because there's a negative inside of a square root, we're going to write that as I times the square root of 5. Sometimes you'll see that people prefer to write the real part, or the factor, the multiplied by the real factor, but write it on the right-hand side of it. I prefer not to write it like that because sometimes it's a little bit hard to distinguish if the I belongs inside the radical or not. Whereas if you write it this way, you know that we're not talking about an I inside that radical. Now, let's look at these numbers a little bit more, because when we multiply them and divide them, example, suppose that we have the square root of negative 3 times the square root of negative 5. We cannot say that that is the square root of negative 3 times negative 5. If you remember, when we had the property which said the square root of A times the square root of B, this equaled the square root of A times B as long as the square root of A and numbers. But because the square root of negative 3, well, we can write the square root of, and we can write the square root of negative 5 as I times square root of 5. But when we do that, if we multiply I times I, we get I squared times the square root of 3 times the square root of 5, and now we've got real numbers here, so that's going to be the that's equal to a negative 1, so this is minus the square root of 15. Whereas if you had misused the property multiplying or dividing these numbers. Let's do another example. Suppose that we have the square root of negative 12 divided by the square root of 3. First, write this as an I number. That's I times the square root of 12 divided by the square root of 3. Okay? Let's, in this case, which is 4, let's take it to the outside. So we have I times 2 times the square root of 3 divided by the square root of 3, and we can cancel the square root of 3 and say that this number is just equal to 2I. Now let's do one more. What happens if we have in the numerator and denominator an I number with a negative inside the radical? So suppose we have the square root of negative 16 divided by the square root of negative 3. Notice that we cannot write this under one radical because neither one of these are real numbers, and that property doesn't work. So what we're going to say is this is, and this is I times the square root of 3. The i's are numbers. They're the same factor. Those cancel out. And now we can say the square root of 16 is 4 over the square root of 3. And we can rationalize this by multiplying the denominator by the square root of 3, the numerator by the square root of 3. And finally, we end up with 4 times the square root of 3 divided by the square root of 9, which is just a plain 3. It's a real number. Okay? All right, let's do one more thing in this segment, and that is to look at powers of I. Okay. We know that I squared is equal to negative 1. What about I cubed? I cubed is the same thing as I squared times I. But I squared is negative 1, and so this is nothing but a minus I. Turns out that I cubed is just equal to a minus I. What about I to the 4th? That's the same thing as I squared times I squared. I squared is negative 1, so we have negative 1 times positive 1. So it turns out that I to the 4th is equal to 1. Well, what about higher power? Well, since we know that I to the fourth is 1, we can write this as I to the fourth times I to the fourth times I. But I to the fourth is 1 times 1. All we're left with is a plain I. So when you have powers of I, what you're going to end up with is some, or it's a negative 1, or it's an I, or it's a negative I.